We start with the Gauss law, and in this case, this is the sphere case. So we have our Gauss surface is equals to 4 pi r squared, and we get our expression for electric field. We start with A. We are finding this electric field where this R is less than the R naught. So we first relate this charge density with the Q enclosed, and this is the volume which the enclosed charge. So this is given by 4 per 3 pi r cube. By this we know Q enclosed equals to rho e 4 per 3 pi r cube. So E is equals to this thing. We substitute the charge enclosed inside. We get the rho e 4 per 3 pi r cube over 4 pi epsilon naught r squared. So we can cancel out. We get this is equals to rho e r 3 epsilon naught. So actually here you can see in this range this electric field will increase linearly with this r, because you can see actually when this Gauss surface increases in this range, the more charge will get enclosed, so the electric field increases. Now we go to the B. B is in the range between R1 and R0. So we can draw somewhere here. We apply back to the same formula, but in this case, this Q enclosed equals to the rho e multiplied with the volume, which is 4 per 3 pi r naught cube. Because you can see in the second case, in case B, this will enclose all the charge until it reaches the R naught, which the volume of this internal non-conducting sphere. And again, we substitute this Q enclosed inside the formula. E 3 pi cube over 4 pi epsilon naught square. This is equals to rho e r naught cube over this 3 epsilon naught r squared. You can see here this is proportional to 1 over r squared, and this is reasonable because until after this r naught, right, they have no more charge, so they will fall off as the 1 over r squared. Now we go to C. C is between R1 and R2. So the range is here between R1 and R2. The question now is what is the charge enclosed in the case C, right? So let us zoom in this part. We will see something like this. Now let's consider the internal this non-conducting sphere is positive charges. And what will happen is that they will induce the negative charge from this conducting spherical shell, which because this is a conductor, so the negative charge will going toward internal surface like this, and of course the outer surface will be positive charges. Now in a given range in the case C, this is between the R1, which until here this is R1, and R2 until here, right? So where we enclose is here. That means the Q enclosed in this case C, this is equals to, no matter with what charge is at the inside, they will induce the same charge. So let's say Q prime and plus this Q induced, and the magnitude will be the same, but they will be the opposite polarity. So we will get a 0 in this case, in the case C. So with substitute 0 inside this formula, we get our electric field is equals to 0. So for case C, this E will equals to 0. Now we go to D. Now we go to D. D is R is greater than R2. So this is enclose all the charge. This is case D. R is greater than R2. In this case, this Q enclosed will equals to this rho E multiplied with 4/3 pi R naught cube, and plus this positive Q. This is due to the internal non-conducting sphere, and this spherical shell outside here is have a positive charge. So we will enclose both of this charge. Now we substitute back to this the equation for our electric field. We will get rho E 4/3 pi R naught cube plus Q over the 4 pi epsilon naught R squared. This is equals to rho E R naught cube over 3 epsilon naught plus Q over 4 pi epsilon naught 1 over R squared. So this is the answer for D.